Welcome to this video on United Nations Sustainable Development Goals, their significance, and how robots can be instrumental in achieving them. The world faces numerous challenges from poverty and inequality to environmental degradation and climate change. In 2015, the United Nations adopted the Sustainable Development Goals to address these issues. These consist of 17 interconnected goals, each with specific targets, all aimed at creating a better, more sustainable world by 2030. Let's take a closer look. The goals encompass a wide range of issues from ending world poverty to gender equality through to clean energy, climate action, and various other goals. But why are the SDGs so crucial? They provide a roadmap for tackling global challenges in a coordinated way. They promote inclusivity, protect our environment, and aim to leave no one behind. They set clear objectives and deadlines, driving global efforts. Now, let's explore how robots can play a vital role in achieving the SDGs. Sustainable Development Goal number 1, no poverty. Robots like FarmBot automate planting and harvesting, increasing crop yield and thereby helping small scale farmers to escape poverty. The Da Vinci surgical system enhances healthcare by aiding in precise, minimally invasive surgeries, thereby reducing risks. Educational robots such as Now and Pepper assist in teaching personalized learning and skill development in classrooms. Robots in household tasks reduce the burden of unpaid caretaking work, facilitating greater participation of female workforce. Robots maintain and operate solar and wind farms, improving the energy efficiency and thereby supporting clean energy. Promoting access to robotics and tech education helps reduce technology disparities and inequalities. Drones monitor environmental changes, tracking deforestation emissions, and protecting wildlife. Robotic, remotely operated vehicles and robots like sea gliders and wave gliders are used for oceanographic research. Finally, talking about the application of service versus industrial robotics. Industrial robots are defined by ISIC and recognized by IFR and are widely used across sectors. They're pivotal in agriculture ISIC A to B, including subcategories like food processing, textile, and electronics. They are involved in ship, locomotive, airplane, and spacecraft construction ISIC 30. Service robots address diverse tasks within specific application areas APs. They contribute to agriculture AP1 by assisting in crop cultivation, livestock farming, and milking. In professional cleaning AP2, they enhance efficiency by handling tasks from floor cleaning to window and wall cleaning. In the medical field, AP6 robots assist in diagnostic surgeries, rehabilitation, and lab tasks. In critical situations like fires or disaster relief, AP7 robots minimize the risks. In summary, these two robots, industrial and service, significantly impact various industries, enhancing efficiency, safety, and productivity in agriculture, manufacturing, logistics, healthcare, and many more professional domains across different ISIC categories and AP categories. Now, we're going to talk about some of the challenges faced and robotic solutions for SDG 6, which is clean water and sanitation. The first challenge is lack of safe water access. Autonomous drones or ground based robots can deliver clean drinking water to remote areas. Organizations like WaterGen use robotic atmospheric water generators, AWGs, to provide clean water in remote and disaster affected regions. Some of the ethical considerations are we have to ensure equitable access to these technologies, especially for marginalized communities. Transparent and inclusive distribution systems are crucial to prevent disparities. The second challenge is poor sanitation facilities and water quality. So, the sanitation robots can improve waste collection and processing, especially in areas with inadequate facilities, and autonomous robots and drones can monitor water quality. The Remote Intelligence Laboratory employs sanitation robots in refugee camps and automotive underwater robots like Sailboy monitor water quality. One of the ethical considerations we have to keep in mind is to ensure dignity of labor is maintained and avoid labor exploitation. Another major challenge is aging infrastructure and no leak detection. So, inspection and maintenance robots can assess the condition of aging water and sanitation infrastructure and patrol water distribution networks, identifying leaks. In Netherlands, Peacon Robotics inspectors navigate sewage pipes, while Singapore uses pipe bots to detect and address leaks. Some of the ethical considerations that we have to keep in mind is to safeguard the privacy of data collected during the infrastructure assessment and ensure responsible data usage. Maintain transparency in operations and data collection, avoiding unauthorized access to data. Another issue we have is inadequate resource management. So, the Smart Water Program in San Diego, California, combines AI and robotics to predict water demand and allocate resources efficiently. One of the ethical considerations is to ensure resource allocation algorithms are free from bias and discriminatory practices, promoting fairness in management. Thank you. In conclusion, robots are vital for achieving the UN SDGs and creating a sustainable future. Thank you.